Hi everyone, my name is Krishna Reddy.
Concept is find the number of zeros at the end of the given number, right? For example, take 100. So take 100. How many zeros from the right side? Two zeros. Then in the same way, in 1000, how many zeros from the right side? Three zeros. The next one, in 1 lakh, how many zeros from the right side? Five zeros, right? So in the same way, in 120 factorial, how many zeros from the right side? We need to find out. That is the concept of trailing zeros, right? For this, let's look at here 2 factorial. 2 factorial equals to, what is the expansion of 2 factorial? 2 into 1 equals to 2. Any zero from right side? No zeros, right? Then next one, 3 factorial. 3 factorial equals to 3 into 2 into 1 equals how much it is? 6. Any zeros from the right side? No zeros. The next one, 4 factorial. Then 4 factorial how much? 4 into 3 into 2 into 1 equals to 24. Here also no zeros. Next one, 5 factorial. Then 5 into 4 into 3 into 2 into 1 equals to 120. How many zeros from, how many zeros from right side? So 1 0 here. How can we get to 1 0? That's important. Okay? Just look at the concept. 2 factorial. In 2 factorial, 2 participate in the multiplication, but we didn't get 0. Here also 2 participation is there. Here 3 twos participation is there, but we didn't get 0. Here also 3 twos and 1 5 participation. 3 twos and 1 5 participation is there. Then here we are getting 0. Then number of zeros is nothing but how can we get 0? That is the question here. Then 5 into 2. We multiply 5 into 2, we get 1 0. This is totally concept based on 5 into 2 combinations. Right? So let's take 5 factorial. 5 factorial, like how many 5s are there? 1 5 is there. Into how many 2s are there? 2 power 3. Then so we have only 1 5 and 3 twos. Then how many combinations of 2 into 5? 2 into 5 combinations how many? Then 2 here 1, here you consider 2 1, here it is 5 1. Then it's equals to how many combinations? 1 combinations. That's why we have only 1 0 at the end of the 5 factorial. Clear, right?
So now coming to the question, first question. Then from this equation we pick only 2 powers and 5 powers. For that, so for this we are doing here factorization. Then let's start with 20 power 5. 20 can be written as 4 into 5. 4 2 square, right? Then 2 square into 5. 2 square into 5 whole power 5 into 15 can be written as 3 into 5 power 12 into 13. In 13 we don't have any 2's and powers, then 13 negligible, then 13 cancel. Then 12 can be written as 4. 4 into 3 4. 2 square into 3 power 16. Again finally 30 can be written as 2 into 3 into 5 power 8. Then so now take only 2 powers. 2 power 2 5's 10 plus next again 2 16's 32 plus here it is 8 into next take 5 powers. So 5 power 1 5 plus 12 plus here it is 5 power 8 8. So finally it's equals to 2 power 50 into 5 power 25. 2 power 50 into 5 power 25. Then how many combinations we are getting? 2 into 5 combinations. 2 into 5 combinations. For this one small trick is take only least power. Take least power. Least power is nothing but number of 5s 25, but number of 2's 50. So nothing, combination is nothing but 2 into 5, right? From here we are getting only 25. Take least power, that is nothing but number of combinations, right? So number of combination equals to 25, that is the number of zeros equals to 25. 25 is the number of zeros at the end of this expression. So answer is 20. Answer is 25. So answer here it is 25. Clear, right? Then next question. So now look at the question and try to solve it. So look at the question, try to solve it. Find the number of zeros at the end of this expression. So now take it 3 power 2 factorial into 5 power 4 factorial into 7 power 6 factorial into 11 power 10 factorial into and so on 101 power 100 factorial. Right? 3 power 2 factorial into 5 power 4 factorial into 7 power 6 factorial into so 11 power 10 factorial into and so on into 101 power 100 factorial. How many zeros at the end of this expression? We know about it, right? To find number of zeros we need 2 into 5 combinations, right? So from this entire expression, so we pick 2 powers and 5 powers. So look at the expression 3 comma 5 comma, just look at the series 3 comma 5 comma 11 and so on. It's 101. Which series it is? Prime number series. So prime number series. So just have a look on this. So 3 5 7 11, what is the prime number series? 3 5 7 11 13 17 19 23 29, right? 31. So look at the series. So did you find out any two multiples here? We didn't find out any two multiples here, so that's why. So for this entire equation, so then we find out 5 multiples, but we need not to find out any 2 multiples. So that's why number of zeros for the expression is number of zeros at the end of this expression equals to 0. Number of zeros at the end of this expression equals to 0. Answer is none. The reason is that here we have the 5 multiples, but we don't have any 2 multiples in this expression. Reason is that this series is prime number series, right? Clear about it? So whenever it is a prime number series starting from 3, so we didn't have any 2 multiples. Without 2 multiples we can't find out zeros, right? According to our concept, 2 into 5 combinations we are getting the 0, but here we have 5 multiples, but we don't have any 2 multiples, right? So that's why here number of zeros of this expression equals to 0. Answer is none, right? I hope all of you clear about it, right? The next. So now look at the question. This one is the second model in finding the number of zeros, right? So that is the first model. This one is the second model, right? So find the number of zeros at the end of the 100 factorial. So you know about it. You know the concept, like the number of zeros equals to so number of zeros equals to what? 2 into 5 combination, right? So in 2 into 5, which one is the highest number? You divide with 2. Here we are doing successive divisibility with 2 and successive divisibility with 5, right? So let us about take 2 and do successive divisibility. We are getting more number of 2's. Then in the same way we are divided with 5, we are getting less number of 5's. So that's why I'm taking here highest number from this expression. 2 into 5. In 2 into 5 we take highest number, that is 5. Take 5 and divide it, do the successive divisibility with 5. So 100 divided with 5. So take quotient value. In 105 cancels how many times? 20 times. So any remainder? So 0 is the remainder. Again do successive divisibility with 5. In 25 how many times? 4 times. Take only quotient values. 5 4s are 20, right? So remainder again equals to 0. So how many 5s? So 4 divided with 5. So any cancellation? No cancellation. 0. Here it is remainder 4. Then so look at the concept. We don't have any use with these reminders. Here we don't have any use with these reminders. Just take quotient values here. So below 100 24 0 are the quotient values, right? 24 0. Now we add all these values. 20 plus 4 plus 0, totally it's equals to 20 plus 4 plus 0, it's equals to 24. Now number of zeros are 24. Simple process, divided successive divisibility with 5. That is the concept to get so number of zeros, right? So let us suppose go to the next question, that is 120 factorial. Take 120. So take 120 successive divisibility with 5. How many times? 24. Remainder equals to 0. Again 5 times 5. Successive divisibility with 5. How many times? 4 times. Remainder equals to 4. The next one divided 5. 0 times. Remainder equals to 4. There is no use with this remainder. Just add only coefficient values, not coefficient, quotient values. I'm sorry for this. So add only quotient values, then sum of quotient values 24 plus 4 plus 0, it's equals to 28 zeros at the end of 120 factorial. So right, so clear. In the same way, 143 factorial divided with 5, successive divisibility with 5. How many times here it is? 2 times. Here it is 8 times. Remainder equals to 3. Again 5. 5 times. Remainder equals to 3. Again 5. How many times here? 1 time. Remainder equals to 0. Then process completed, right? Again with 5. 0. Remainder equals to 1. Now add. So no, there is no use with these reminders, then eliminate it. Just take the sum of all quotient values. 28 plus 5 plus 1 plus 0, it's equals to 29. 34, number of zeros equals to 34. Clear? I think all of you clear about it. Then next go to the now next one, find the number of zero. Continuation. So continuation here, find the number of zeros at the end of the 500 factorial. Take 500, successive divisibility with 5. Then how many times? 100 times, remainder 0. Same way 5, how many times in 100? 20, remainder 0. Again 5, how many times? How many times in 25? 4 times, remainder 0. So next one, 5 divide is divisibility with 5, 0, then 0 times, then remainder equals to 4. Now don't have any use with these reminders, then add all what? Quotient values. Then 100 plus 20 plus 24 plus 0, total it's equals to not 24, it's 4. 100 plus 20 plus 4, it's equals to 124. Number of zeros at the end of 500, 124. So next one, 750. So 750 successive divisibility with 5. Here it is 1 time, 5 times 0, right? So 150 times, remainder 0. Next one 5, then in 150 it is 30 again. So don't have any use with reminders and then skip it. Then next 30, in 35 how many times? 6 times. In 6 5 how many times? 1 times. Then total 180. So 150 plus 30 plus 6 plus 1, total it's equals to how much? 187. So 187 is at the end of this expression. Now look at this question. 11 12, 11 into 12 into 13 into 14 into and so on, 170 into 10 factorial. Then here we have 10 factorial. 10 factorial into 11 into 12 into 13 into 14 into 170 continuation series. It is nothing but 1 into 2 into 3 into and so on into 169 into 170. Total it is nothing but 170 factorial. This belongs to 170 factorial, right? Now in 170 factorial, how many zeros? Take it, successive divisibility with 5. In 170 successive divisibility with 5, how many times? 173 times, 15, 20, 4 times, right? So in 34 5, how many times again? 6 times. 5 here, 1 time. Clear? Its total how many zeros? 41. 41 zeros at the end of this expression. I hope clear. Then I hope all of you understand about it. Then next move to the next one. Right, so all of you now look at the question. So this one is the previous question asked in Accenture, not Accenture, asked in, I think it is in Wipro. Right, find the highest power of 2 in the following expression. Don't confusion at all. Then highest power of 2. So whenever they are asking about highest power of 2, it is nothing but we need to find out how many number of 2's in this expression, like how many number of zeros in that expression. In the same way here we need to find out how many number of 2's in that in this expression. For this we divided into two factors. Now 18, so 1800 can be written as 18 into 100 into in 25 we don't have any 2's, right? Cancel it. So this 4 can be written as 2 square, 2 into 8, 2 power 2 into 8, 16 into in 21 we don't have any 0 any 2's. In 45 we don't have any 2 multiples, then cancel it. Then 1800 in 18, so 18 can be written as 2 into 9 into 100 can be written as how 4 into 25, right? 4 into 25, 4 can be written as 2 square into 25 into 2 power 16. This much of 2's we have in this expression, right? Total 2 power 1 plus 2 plus 16, it is 2 power 19. Total number of 2's in this expression is 19. Simple question, right? So whatever the terminology they are using, our concept is so find out the number of 2's here, that's it. So number of 2's in this expression, take only 2 multiples from the entire equation. Clear? Separate the 2 multiples, that's what. Clear? Thank you. The next one. So now look at have a look on the question. Find the highest power of 2 in 20 factorial. Find the highest power of 2 in 20 factorial. Have a look. Take 20. Same thing, right? As a number of zeros, what we did is do the successive divisibility with 5. In the same way, take 20 factorial and do successive divisibility with 2. Do successive divisibility with 2. Then how many times? 10 times. Remainder 0. Skip the remainder values. Then in 10 again 2 how many times? 5 times. 2 here 5 times. In 5 2 how many times? 2 times. In 2 2 how many times? 1 time. Then say in 1 2 cancels, no cancellation, then stop the process. Then add all these quotient values. 10 plus 5 plus 2 plus 1. So 10 plus 5 plus 2 plus 1, it's equals to 17, 18. The total number of 2's in 20 factorial equals to 18. Total number of 2's equals to 18. So next one, find the highest power of 3. Find the highest power of 3 in 67 factorial. Take 67, do successive divisibility with 3. Successive divisibility. Right, then 2 times, here it is 22 times, remainder, skip the remainder. Again in 22 3 how many times? 7 times. In 7 again 3 how many times? 2 times. Into 3 how many times? No cancellation, then stop the process. Into 3 cancels, no, right? Then total add all quotient values. 22 plus 7 plus 2, 22 plus 7 plus 2, total it's equals to 24 plus 7, 31. So number of 3's equals to 31. Number of 3's equals to 31. Okay. Then now next question. So look at, try to solve it. Find the highest power of 5 in 4 factorial. Now same thing, right? Find the number of zeros and as same as find the highest power of 5 in some factorial. So process is same, successive divisibility with 5. So for the highest power of 5 or find the number of zeros, process is same, successive divisibility with 5. Now 140, take 140, then successive divisibility with 5. Then how many times in 40? 100 times. It is here, it is 248 times. Then again 5, how many times? 5 times. 5 1 time. Total it is 29, 34. Number of 5's equals to 34. Number of 5's 34 as well as number of zeros also 34. The process of finding the number of zeros and number of 5's number of 5 both is same. Clear? I think all of you clear about it. Then next one, find the highest power of 11 in 243. So take highest power of 11 in 243. Take 243, do successive divisibility with 11. How many times it is? 2 times 22, 23 again 2 times. Right? Remainder forget the, so not forget, skip the remainder. We don't have any use with the reminders here. Again 11 here 2 times, into 11 cancels, no. Total 22 plus 2, 22 plus 2, add all quotient values. 22 plus 2 equals to 24. Right down. Then right? Now look at, so look at find the highest power of 6 in 70 factorial. So all of you doing like this, I think all of you doing like 70 divided with 6, right? So it is not correct process to solve this question. It has some intention, right? Then so look at the previous questions, then we are find highest power of 2, 3, 5 and again 7, 11. This 2, 3, 5, 7, and which numbers, these numbers are what, prime numbers, right? It is possible to find number of zeros. Here we have only prime numbers, that's it. Then 6 can be written as what, 6 equals to, how can we get the 6? So combination of 2 into 3. So combination of 2 into 3. Clear? Which one is the highest here? 3 is the highest number. Then if you divide 70 with 2, you get more number of 2's divided by 3 compared with 3 are less, right? Then that's why we take it highest number. In 2 into 3, which one is the highest? 3 highest. Now do successive divisibility with 3. So 3 with 7, how many times? 70. So it's equals to how many times now? 23 times, right? 23 times, it's 69. Again 3, 7 times, in 7 3, 2 times. So in 2 3, no cancellation. Finally it is 23 plus 7 plus 2, 25 plus 7, 32. So number of 3's equals to 32. In the same way, number of 6 equals to, then let us suppose take 2 here. 2 in 70, how many 2's we have? So 2 equals to how many times? 30. 5 times. Again 2, how many times? So in 35, in 17 times 34. So 2 here 8 times, 2 here 4 times, 2 succeed divisibility 2 times, 2 here 1 time. 1 plus 2 7, 1 plus 2 sorry 3, 3 plus 4 7, 7 plus 8 15. So 15 plus 17, 32. 32 is 67. So total number of 2's equals to 67. 2 power 67 into 3 power, how much it is? So 3 power 27, 27 to 32, 3 power 32. So 2 power 2, look at the 2's 69, right? Look at 3 is 32. Total number of 3 is 32, total number of 2 69. So what is our concept? So whenever we are getting number of 6 is 2 into 3 combinations. The further take least value. Total how many combination we have? For this we take least value. What is the least value? 32. Now so number of 6's equals to 32. Clear? Number of 6 equals to 32. In the same way, look at here, find the highest power of 9 in 120 factorial. 9 can be written as 3 into 3. Both numbers are same, right? Divided with 3. 120 divided with 3. 40 times. Again 3. 13 3 is 39. 13 3 is 39. Again 3. 4 times. Again 3. 1 time. Right? So total it's equals to 40 plus 13, 53, 57, 58. It is 3 power 58. So 3 power 58 is nothing but number of 9's equals to 58. So it is wrong. Here number of 3's equals to 58. Now we need to find out number of 9's how many. So for this we divide that 58 into, we multiply. 58 can be written as 29 into 2. So 58 can be written as 29 into 2. It's equals to 3 square whole power 29. 3 square whole power 29. It's equals to 9 power 29. 9 power 29. Now number of 9's equals to how many now? 29. So number of 9's equals to 29. That is the concept of finding the number of zeros. So first model, they give the expression. From that expression we need to find out the 2 powers and 5 powers. Second model is on factorial. Here it is highest power. These are the 3 models in to find the number of zeros. All of you clear? Yes? Then so finally, so this is the concept, right? So finally it's equals to, first concept is expression. So from this expression we need to find out the number of zeros. For that we find out 2 powers and 5 powers. So then second one on factorial. So questions on factorial. So next concept is highest power concept. So highest power. So these are the three models in so finding the number of zeros, right? So all of you, good luck. Thank you so much.